We present real-time and photorealistic neural hand rendering. Our approach is the first method for real-time neural hand rendering under novel camera and hand poses with unprecedented photorealism. It is trained using a multi-view image sequences and, at test time, the hand model is driven using hand pose parameters. We also implemented a live demo where the tracked user's hand drives the pre-trained model, photorealistically in real time for the first time in literature. Here, we show results on more identities. Our approach captures a wide variety of hand articulations and can be rendered from an arbitrary camera viewpoint. It can also be observed that we photorealistically capture hand pose dependent effects, such as wrinkles and shadows. Here, we show our model can also capture camera view dependent effects when we change camera parameters while keeping the hand pose fixed. Here, we compare to the previous works A-Ni RF and Lisa, which we apply to our person-specific hand model setting. We found that their results are blurry and contain clear visual artifacts. In addition, none of these methods can run in real time. Here we examine different means of conditioning and representing the canonical space. Naively conditioning the MLP on the hand pose leads to blurry results. While a per bone canonicalization improves results, the rendering speed is not as fast as our method. We also note removing hand pose parameter conditioning leads to loss in hand pose dependent effects like shadows and wrinkles. Next, we evaluate the different design choices of our method. While removing the mesh-guided sampling and the super resolution module does not lead to a significant drop in quality, their rendering time is slower than us, and not real time. Here, we show that removing the perceptual loss leads to a clear degradation in quality, such as missing high-frequency components. We also show that applying the perceptual loss on the full image as opposed to a patch-based manner leads to a clear improvement in the rendering quality. This further shows the importance of our design choices in reaching a performance that is both high quality and real time. Next, we show an application of our method. As our method relies only on hand pose parameters at test time, it can also be used for other exciting applications such as motion retargeting using hand pose parameters from any identity. Here we show multiple identities being driven by common hand pose parameters. Also note that our method can capture identity-specific details like nail pate. Thanks for listening.